Hey, good afternoon. Welcome back. Happy Friday. So again, we start on page 80, but we'll take our quick look at the calendar. Oh, we do have a special guest. Everybody say hi, Josh.
Hi, Josh. Hi, Josh.
All right. So we have not very much left in the semester, as we can see. Today is day 3 on algebraic fractions. Next time, Monday, we're going to talk about equations involving the things that we've been studying for 3 days now. Wednesday is our review day. I do have a quest that I will hand out. I think I'll hand it out today. It's not going to count for anything. It's just for practice. There's an answer key on the back. And then Wednesday is our review, and then this course is officially ending a week from Monday with our final exam on May the 20th, okay? 12:30 until 3. It's a little bit bigger than our normal window. Questions on the calendar? Okay. So page 80, the plan for today is to just continue with what we were doing last class. We were adding and subtracting fractions that were quite complicated. That's all that we're doing today. We're going to do 3 examples, and then you guys are going to go to town on the group activity. These problems take a long time, so you'll have plenty to do after we do our 3 examples. So let's see if we can refresh our memory on how to handle these guys. So remember, step 1 was to factor all these denominators completely. So 8x seems like it's factored, but we're going to even factor the 8. We're really going to get it down to basics. How does 8 factor? 2 times 4, and then 4 will go even more, times 2, right? Get it all the way down to primes. So there's my 8x. Can you guys take a moment, do the same thing with 6x cubed? Just factor that 6. And I'm going to be kind of silly, and I'm going to write x instead of the x cubed, just so I really see the 3 x's, right? I mean, that's factored way further than anybody really should. And then we start putting things into our special diagram here with the ovals. We're looking for things that overlap. That's what you got to find first. So what do we see that's the same in both? There is a 2 that is the same in both. I'll circle that in purple. And there's an x. I'll put a box around that. Is there anything else that's the same in both? I think that's it. So right there in the middle, what are we putting? 2x. And then in the left-hand part of the left oval, you're putting everything else that was blue that isn't there yet. So I'll put in blue. What else do we have? 3 and x and x. And in green, what's missing? 2 times 2. So there we go. And how do we find the LCD? Just multiply everything together. That's the whole point of this oval thing, is we just multiply it all through. And so I'll just write it all in purple here. It's going to look funny the way I'm going to write it, but 3 times x times x times 2 times x times 2 times 2. But I really do think there's something nice that's going to happen by writing this denominator, or writing that thing, in a very funny way. And the nice thing that's supposed to happen is it should be clear to us what the old denominators were, and then how to build the new denominators. So let's write the original fractions. What did we have first? It was a 5 over. And then instead of 6x cubed, I'm going to write this factored version of things. 2 times 3 times x times x times x. That's my 6x cubed. I'm just putting it down here. 2, 3, x, x, x. And then the other fraction was 7 over 8x. We're writing that as 7 over what? Good. Thank you, Josh. 2 times 2 times x. So we've got our 2 fractions. Just rewrote them with the funny looking denominators. But here's the point now, is it should be easy for us to figure out what's missing. The goal for these denominators is all that purple stuff. Each of the blue and green have some, but not all of the purple. So we just got to fill in purple what's missing. What is the blue missing that's up there in purple? We got a 2, a 3, and 3 x's. A 2, a 3, and 3 x's. What's left is the 2 times 2. So over here, I would really like to put a 2 times 2 in the bottom. but I can't go around doing that without putting it on top. Okay, this green denominator, look at what it has, look at what it wants in that LCD. What's missing? 3 is missing, and 2 of the x's are missing, right? So, and you can kind of cross them off temporarily. 2, 2, 2x, 2, 2, 2x. This is what we need, right? 3 times x times x. So we'll put that over here, 3x and x. But then right away, same thing upstairs. And at this point now we're done writing these things in a funny way. I'm not going to write x times x anymore. I'll write x squared. That's the shorthand for writing it. But I think listing them all out like that makes it clear what's missing and then how do you fill in to build the right denominator. Okay, the new fractions. We're going to multiply on the top. Remember we had this kind of strange rule. I said never multiply on the bottom, but always multiply on the top. So 5 times 2 times 2 is what? 20? Divided by. And now we're just going to, like I said, stop writing it with all the x's written out. So 2 times 3 is 6, times 2 is 24, x cubed. Is that right, when you multiply everything out downstairs? And then in the second fraction, 7 times 3 times x, 21x squared. Thank you, Jenny. Divide by. It is, and I don't know if you actually did the multiplication. I mean, it's supposed to be it's supposed to be the same as that denominator. It must be 24x cubed, but it's kind of nice to check and multiply all this through, and you'll find it's 24x cubed. Was it a plus or a minus from the beginning of this problem? Plus, so plus in between. Okay, quick question. Am I allowed to cancel the x squared here with the x cubed, which leaves 1x on the bottom? It's all multiplication. So is it allowed? Absolutely. Is it recommended? No. Because if you cancel, you're just going back to the reduced fraction that you started with. You are intentionally building a fraction that's not reduced. But what's the nice thing about these two fractions? Same denominator. That's the whole point. So even though you'll always have the opportunity to cancel, don't. So we are going to add, and then maybe we could cancel after. But for here, we're just adding. So upstairs, just copy it. 20. Yep, good. Do I add these denominators? No. When you add fractions, you just copy that like denominator. Okay. Your choices are upstairs and downstairs. Which one is all multiplication? Downstairs. So if we can cancel something downstairs, downstairs is ready to go. Is upstairs ready to be canceled? No, it's addition. Any addition and subtraction we know we can't cancel. So maybe we can factor. Can you factor anything out upstairs? 20 and 21, nothing goes into them. There's x's in the second one, but none in the first one. We're done. There's nothing to do. Again, it's tempting to maybe try crossing off 20 and 24. Yeah, they do have a common factor, but this plus sign says you can't do anything. That's our answer. Questions on that?
So it would not be 41.
No. So it's, yeah, other stuff you can think to do is maybe combine those two upstairs. What's wrong with that? They're not like terms, right? 20 has no x's in it. It's never going to go with something that does. Yeah, that's another issue that, you know, oftentimes doesn't even come up in class is just stopping, because oftentimes on tests you'll do exactly the right thing, you'll get to the right answer, but then you don't stop. You invent new algebra rules and you combine things that you can't do. So yeah, it's important to know the rules, but it's also important to know when there's no more rules that apply. like in this example. All right, next page. Okay, first step, what do? Factor all the denominators. We can. Yep, difference of two squares, x squared minus 9, it factors. Okay, x plus 3x minus 3 in some order. And the other one factors in a different way. So this one we can factor out the 2. Right, we spent a lot of time talking about factoring. It all comes back to either pay off if you've got a good foundation in factoring, or it comes back to haunt you again if you still can't factor, because now you can't do fractions problems because you still can't factor. Okay, I'm looking for the stuff that goes in the middle. X plus 3. I'm going to keep it in parentheses. On the far left, what goes in that blank space? X minus 3. I'll keep that in parentheses. And the far right is a 2. I'll put it in parentheses just for good measure. So you can rewrite this as x times x minus 3 times 3. Like that's okay to do. But is this thing in factored form? Factor means it's the main operation is multiplication. But what's the main operation in this one? There's a subtraction still. So even though you factored them individually, you haven't dealt with the real problem, which was that subtraction sign in the middle. Okay, let's move on. So then the LCD, we just copy straight across. X minus 3, x plus 3, 2, all multiplied together. That's correct. You can put that in any order. Traditionally, the 2 would go in the front. You don't need to. I was just trying to be consistent. Okay, now we're going to rewrite our original fractions, but in factored denominator form. So that minus 9 over, just put the factored version of the downstairs. So minus 9 over x minus 3x plus 3. And the other fraction, again, write it with the factored denominator. So this is now the time where we fill in what's missing. So you've got the denominators in their current form. Up in purple up there, we see what the lowest common denominator should be. And you got to fill in the missing piece by multiplying by the foo-foo. What's missing in that blue fraction? 2. So you multiply top and bottom of that blue fraction by 2. What's missing in the second fraction? X minus 3. So multiply top and bottom by x minus 3. Okay, new fractions. For the blue one, what do we get upstairs when we multiply? Negative 18 divided by, all right, this is where I'm going to take a little shortcut. What's true about the two new denominators? they're both the same, right? That was the point, is that these two new denominators should be the same. So we're just going to abbreviate it, and you have my permission to abbreviate it as well. We'll just call it LCD. We know what the LCD is. It's right there in purple. I never multiply on the bottom. Yeah, I mean, it's not wrong to distribute on the bottom, but it's never going to cancel or simplify or anything like that. So I always leave it. The other nice thing about having it in factored form is that when you get to your final answer, it'll be easier to see if you can cancel something because it's already factored. How about in the other one, green here? Should we distribute here? The answer is yes. We do distribute upstairs, not downstairs. So I'm going to put here an x squared minus 3x divided by what? LCD. Teresa. What are we looking at? Oh, thank you. X plus 3, x minus 3 is what they should have been. Thanks. Any questions so far? Okay, was it an addition or subtraction in the beginning? Addition, so we'll put addition in the middle. And now because we've got the same denominator, we can just add straight across. But there really isn't much to write. I'll just copy it. Minus 18 plus x squared minus 3x divided by the LCD. Are there any like terms to combine upstairs? No. So we can't do anything in terms of mushing stuff together. But we can do something if we rewrite this. This doesn't really look in our standard order, right? Normally, which one would you write first? Normally write the x squared and then 3x and then 18. And when it looks like that, we start to feel maybe we should try to factor. So take a moment, see if you can factor that. So this is our product sum idea. What do we get? Sounds good. Everyone agree with Evan? And now I'm going to stop writing LCD. I'm actually going to write what the thing is that goes down here. So downstairs we had an x plus 3 and an x minus 3 and also what? There's also a 2. I'll put that in the front. And what can we do now? We can cancel. And so this really comes back to Melanie's question. If we had distributed on the bottom, it wouldn't be clear that we can cancel. You'd have to go back anyway and factor it. So I know a lot of people feel like they have to distribute when they see something like what's on the bottom. You don't. So leave it on the bottom every time, and then you can take advantage of the fact that it cancels if it does. So x plus 3 goes, and we'll get our final answer up here, x minus 6 over 2, x minus 3. And again, it's important to know when to say when. 6 and 3, can we cancel? No. Subtraction, x and x. No. 2 and 6. One of these is ready to cancel, but not the other. Which one is cancelable? Is the 2, because the 2 has a times. But it's the 6 that's not ready because of that subtraction. Yeah. Okay, one more for us to do together, and then you'll do a bunch in your groups. But before we get to this last one here on the right, I just want to point out, I've just handed out what would have been our 5th quest. It was supposed to be graded, but a lot of snow days pushed everything back. I have canceled it and just made it practice, so here it is. You've got it. On the back of the last page, you will find the answer key. Many thanks to Teresa for pointing out that I somehow swapped my answers for problems 2 and 3 when I typed up this answer key. So where it says 2, on the very back page, see it says 2A? Cross that off. Those are the answers to number 3. Where problem two, both parts, they're just swapped. Where I answered question 2, all those parts, those are really the answers to question 3. And question 3 is really number 2. So it should be like it is up here. I've already fixed it on this projected document. So I just swapped the 2 and 3. Thank you, Teresa. Okay. Again, if you feel like doing this, you know, it's not going to be graded for credit, but if you want my feedback, give it to me completed on Monday. I'll give it back to you with feedback on it on Friday. Sorry, on Wednesday, which is the last day. Yes, Ben. No, you may not. Yeah. Okay. So let's come back here. One more to do. All right. Again, first step is to factor those denominators. So take a moment. 2 different kinds of factoring downstairs. Okay, we've got our 2 factorings. I've written them. Did I get them right? Okay. What do you look for first? What's the same? M minus 4 is the same in both. Where does it go? In the middle, keep it in parentheses. You've got blank spaces, fill in the other parts. First one, M. Second one, M plus 4, parentheses there. Not really necessary, but I'll just throw the single M in parentheses so it doesn't feel left out. LCD. All that. Just multiply straight across. Should we distribute that? No. If you do, you'll lose sight of what the factors were. The factors are really important, so don't distribute. Okay, original fractions, but now we'll put them in factored form. What was upstairs originally? -2, and then we'll put it with the factored version of the denominator, m minus 4. What was on top in the other fraction? 1, and then factored version downstairs. One of you guys fill Sam in on the correction. Thanks. Okay, what's missing in the first denominator? M plus 4, so we put it downstairs and upstairs in parentheses. What's missing in the second one? Just M. Top and bottom. Should we distribute upstairs? Yes, we should. -2m plus 8. It's real easy to miss that. What's that? Because I made a mistake, but it's really easy to make that mistake. Right? Really easy to make that mistake. 2m minus 8 divided by, what can we put? So you could copy it. What else could we put? I could just put LCD. All right, the next one. Upstairs, just a single M, LCD. There's a plus in the middle. Okay, so then just to add them up, you do have 2 things that combine, 2 like terms. Okay, what do we get? Negative m minus 8 divided by, and then at some point you need to write the denominator. Like at some point, if this is our final answer, we better actually write out what the denominator is, but leave it factored. I think we're good as long as nothing cancels. 8 and 4, are either of them ready to go? M and M? No? Are either of those m's ready to go? Neither m is ready? That bottom one is ready. It's times, but not the top one. That's it. Questions on this? Okay, on the next page, there are a whole slew of these problems for you to do. Goes all the way up to number 7. Now, what do you notice is missing? All the steps. So draw the ovals if it helps you. I mean, you know, you're not going to have ovals on the test, so put them in if you want to. You can put ovals. So let's talk a tiny bit about the final exam. So I will throw you a bone for this final exam and say that you can bring in the perfect power sheet, which you've had before. You can also bring in one piece of paper where you put anything you want on it, front and back. You can, the cheat sheet, okay? 8.5 by 11. Don't bring in like a poster board. Yeah, just like this big. If it doesn't fit through the door, it's too big. Yes, Michelle. Okay. All right. So we got 7 of these things, and we have 40 minutes to do them. It's going to take a while. Go for it. Raise a flag if I can help.